Okay, I think I'm live. And can anyone confirm that in the chat box, please? So that we can start this session. Okay. Okay, thank you, Trends, for the confirmation. So I think we can start the session now. Okay, so welcome everyone for this free video series that is being conducted by the team Cracku. This is for IIM Bangalore UG program. This is a new program that is being started by IIM Bangalore from next year. So they will be conducting an admission test for this particular program. So today's session is on time, speed and distance. So I think we should start with the session now. Okay. So before we begin, these are a few updates that I want to share with you. First is about the WhatsApp channel. So I would recommend you to follow us on the WhatsApp channel, so that because we are sharing free preparation resources and all the important updates about the session that we are conducting, as well as about the entrance exam that is being conducted. Okay, so by joining that group, you will be able to interact with so many of the students who are also preparing for this exam. So it will be a good environment for you to interact with those students. The link is in the description box of this video. So you can just go in the description and join the WhatsApp channel also. And this is about the schedule. Like today it is 4th of November and the session is on time, speed and distance. Like you can see, the session is first. So there will be one more session on time, speed and distance. So I would recommend you to subscribe to this channel so that you don't miss out on any of the sessions that we are conducting for free. And also just like this video so that it can reach out to more students. And you can share this video also with your friends who must be preparing for the IIM Bangalore's UG program. Okay. Also, these are the few free mock tests, 5 free mock tests that we are providing. You can just go on cracku.in. Then you can click on this IPMAT and IIMB UG. You can click on IIMB UG mock test free. Then you will be redirected to this page and you will be able to access these free 5 mock tests that we are providing. Apart from this, the details about the entrance exam are also available on this page. Like there are 3 sections in the exam. Today's class is on quantitative aptitude. Yeah, so you can check the details. But what is more important is this free 5 mock tests that we are providing. So you should definitely check them out and you should definitely give these free 5 mock tests. Okay. So moving ahead. Yeah, so like I told, today's session is on time, speed and distance. This is the class 1. So we'll try to understand this particular concept, how we need to, I have brought in some of the good questions from this particular topic. So before that, let's try to understand all the basic concepts. Then we will deep down with the questions. Okay. So let's start with the understanding the basics. So whenever you will be starting with time, speed and distance, these are the very basic formulas that you will encounter, that are distance is equal to time into speed. I think I am correctly visible. Okay. So distance is equal to time into speed. Time is equal to distance upon speed. Speed is equal to distance divided by time. These are the very basic things that we need to know when we are studying time, speed and distance. So how we are actually getting that distance is equal to time into speed. So let's try to understand that. Okay. Let's say we are taking an example. You are traveling with a speed of 30 km per hour. Just to explain you how we are getting this formula. Okay. So let's say the speed is, let's say you are traveling with a speed of 30 km per hour. Okay. And in the upcoming slides, we will be understanding how these units also work. Just taking an example to make you understand about these 3 formulas. So the speed is 30 km per hour. Okay. And the time that you are, for which you are traveling, be, let's say 3 hours. Okay. So the time be 3 hours. So what will be the total distance that you will travel? Suppose you don't know about any of the formula. So what you will do is, in the first hour you will travel 30 kilometer, right? So let's say you are told to calculate the distance. So what you will do is that in the first hour you will travel 30 kilometers. So you will write here 30 plus. In the second hour also you will travel 30 kilometers. And in the third hour also, because you are traveling for a total of 3 hours. So in the third hour also you will be traveling 30 kilometers. So essentially what you are doing is that just solving this, we will take 30 as a common. Then it will come to as 30 in bracket 1 plus 1 plus 1. So essentially what we are getting is that 30 into 3. Of course the answer will come out to be 90, but the main purpose is what we have done there is that to calculate the distance, we have essentially multiplied the distance, the speed, that is 30 kilometers, with time, that is 3 hours. So this was a small number, like it was for 3 hours, but let's say that the time for which you are traveling is, let's say, 10 hours or 12 hours. So you can't simply put on, let's say, 30, adding 30 for 12 times, right? So that will take a lot of time for you to calculate. So what would be better approach? You can directly use this formula, that distance is equal to time into speed. With the help of just one formula, you can derive the other two formulas also. Because if distance, I am denoting distance by d, so distance is time into speed. Okay. So now if you want to calculate, get the formula for time, so you can just send this s to the denominator. So what you will get is that time is equal to d divided by s. Same you can do for the third thing, that is speed. So what you can write here is that s is equal to d divided by t, right? These are the very basic formulas. I just try to explain you a bit. I hope there must be no doubts regarding this slide. And also, if you have any doubts regarding any slide or maybe of any question, you can just put on in the live chat. Would be happy to answer. So let's move ahead to the next slide. Okay, let's see if you have any doubts. Okay, I think that is perfectly fine. So now, like I told you in the previous slide, that I will be explaining you about the units of speed. So whenever you will be solving the time, speed and distance question, there are two very frequently repeated units. One is kilometer per hour and one is meter per second. So what do these units essentially say? So this particular unit, for example, let's say in the last slide, I took the example that you are traveling at a speed of 30 km per hour. So what does that mean? So speed is equal to 30 kilometers per hour. So this essentially means that in every hour you are traveling a distance of 30 kilometers, right? So in 1 hour you will be traveling a 30 kilometers distance. In 2 hours you will be traveling 60 kilometers and so on. So talking about this unit, if let's say assume that the value to be 5 meters per second. So every second you will be traveling a distance of 5 meters. So in 2 seconds it will be 10 meters and so on. So these are just two units to denote the speed. Okay. I have also explained the units here. Like 1 kilometer is equal to 1000 meters. 1 hour is equal to 60 minutes. 1 minute is equal to 60 seconds. And also notice here that we can convert from kilometer per hour to meter per second, and also from meter per second to kilometer per hour using this particular formula, right? So to convert from kilometer per hour to meter per second, we can just multiply it by 5 by 18. And if we want to convert from meter per second to kilometer per hour, we can just multiply it by 18 by 5. So these are the formulas, but how we are essentially able to get to this formula, let's try to understand that also. So taking this example itself, okay, right. So we have 30 km per hour as the speed. So now we want to convert it into meter per second, right? So you can see here is that 1 kilometer is equal to 1000 meters, right? So we want to convert from kilometers to meters. So we'll write here, instead of kilometers, we'll write 1000 meters so that we can convert it into meters. So we can just multiply it by 1000 divided by, because the r is in denominator. So 1 hour is equal to 60 minutes and 1 minute is equal to 60 seconds. So when we will dividing it by 60, so now the value is converted from hours to minutes, but what we want to convert is from hours to seconds, right? This unit is in meter per second, so we want to convert it into seconds. So now this has been converted into minutes. We can further multiply it by 60 so that this value is being converted into seconds. So we can further multiply it by 60. So just solving this. Okay, so leaving 30 as it is. So this is being multiplied by 5 in the numerator and 3 into 6 in the denominator. That is 30 into 5 by 18. So this is the formula that we are using here. So I just tried to explain you how we are getting to this formula. Of course, you will be using this formula directly, and you would not be using, you will not be trying to solve it this way because it will take a lot of time. But I just tried to explain because it is important to know how we are actually reaching the results, right? Just learning the things won't help. Okay, so you can do the same thing while you are converting from meter per second to kilometer per hour. It is one of the same thing. So I think that should also be very much clear to you. I don't think you must be having any doubts with this particular slide. Okay. Okay, I don't think you have any doubt. So I think we can continue with the session. Okay. So after this, it is okay. So we have two important concepts here. First is, for the same distance traveled, if the ratio of speeds of A and B, we are taking let's say two persons or two people, A and B, the ratio of their speeds is in the ratio A is to B, then the ratio of the time taken will be in the ratio 1 by A is to 1 by B, or we can write it as B is to A also. There's one more concept down also, but let's try to understand this one. Okay, so same distance. Okay, so here we were given that for the same distance. Okay, let's take the distance to be 50 kilometers. Okay. So the distance that we are traveling be 50 kilometers. So we have to travel a distance of 50 kilometers. And also, let's say there are two persons, person A and person B, and let's say the speed of person A be 20 kilometer per hour. Okay, and the speed of person B, let's take it to be 30 kilometers per hour. So we have taken the speeds of two persons as 20 kilometer per hour and 30 kilometers per hour. What is the ratio of the speeds? So we can write it as SA is to SB. SA is basically representing the speed of A and SB is basically representing speed of B. So how, okay, so SA is to SB will be, so 20 is to 30, essentially we are getting is 2 is to 3. This is the ratio of speeds of the two persons. Now we should calculate the time that they are taking. So the time taken by A, let's denote it by TA, that is time taken by A. So that will be equal to the distance, that is 50 kilometers we have taken distance. So 50 divided by the speed of A is 20 kilometers per hour, that is 20, and the time that B will take will be equal to, again, the distance, that is 50 kilometers divided by the speed of B, that is 30 kilometers per hour. Okay, so we'll just cancel this out. So the time that A is taking is 5 by 2 and the time that B is taking is 5 by 3. Okay, so now because the ratio, okay, so now we need to check the ratio of the time that they are taking. So the ratio will be TA is to TB, which will come out to be 5 by A is to 5 by B. We will just solve this ratio. So 5 and 5 will cancel out. What we are left with is 1 by 2 is to 1 by 3, or we can just take the LCM and multiply so that we can simplify this ratio further. So let's say the LCM of 2 is to 3 is of course 6. So we will multiply this ratio by 6. Okay, 1 by 2 into 6, 1 by 3 into 6. I hope it is visible. Okay, so I'll write it here. So this will come out to be So this will cancel out to be 3, this will cancel as 2. So essentially what we are getting here is the ratio is 3:2. This is the ratio of time. So you can see that for the same distance being traveled, if the ratio of speeds of two persons A and B is in the ratio 2:3, the ratio of the time that they will take will be in the ratio 3:2. So this was essentially what this first point was trying to tell us, that for the same distance traveled, if the ratio of speeds of A and B is A:B, then the ratio of the time taken will be in the ratio 1 by A is to 1 by B. So here we got 1 by A is to 1 by B. We further simplified it and we got it as 3:2. So I think the first point must be clear to you. Now let's try to understand the second also with the help of an example. Let's first try to read it. So for the time being same, if the ratio of the speeds of A and B is A:B, then the ratio of distance traveled will also be in the ratio A:B. Okay, so in the initial case, it was that the distance traveled was same in the two cases. But in the second, it is given that the time for the two cases is same. So let's try to understand this also with the help of an example. Okay. So I should clean this. Okay. Right. So for the second concept, the time has to be same. Let's say the time is 5 hours. So the time for the two cases are, let's say, 5 hours. Again, the speed that we let in the last case, we should let the same speed. As A represents the speed of A, let it be 20 kilometers per hour. And the speed of B will be equal to 30 kilometers per hour. Okay. So the distance that will be traveled, so we know that distance is equal to speed into time, right? So the distance that will be traveled will be, let's say, dA is the distance that A is traveling, and I'll write dB for the distance that B is traveling. Okay, so dA is equal to SA into time. Time is constant for both the conditions. So SA is 20 and time is 5. So essentially what we are getting is 100 kilometers, because the unit is in kilometer per hour. So this will come out to be in kilometers. So taking the second condition, that is the distance that is traveled by B, it will be equal to the speed of B, that is 30 kilometers per hour. So SB into T. T is the time. So essentially it will be 30 into 5, that is 150 kilometers. Okay, so now we need to check the ratio of the distance that is being traveled. Okay, so dA is the distance that A is traveling, dB is the distance that B is traveling. So the ratio will come out to be 100 is to 150. We can cancel out with 50, so it will come out to be 2 is to 3. So you can see that for the time being same, if the ratio of speed, of course the ratio of speed is 2 is to 3, because the 0 will cancel out. So the speed ratio is 2 is to 3 for the time being same. So the ratio of distance also comes out to be 2 is to 3. So that was about the second important concept from this page. So if the time being same, for the time being same, if the ratio of speeds of A and B is in the ratio A is to B, then the ratio of distance traveled will also be in the ratio A is to B. Okay. For the time being same, if the ratio of speeds is A is to B, then the ratio of distances will also be in the ratio A is to B. So I think that is also a very much clear to you. Let me check if you have any doubts. Okay, I think that is very much clear to you. You can ask your doubts. If you have any doubts, you can put it in the live chat. Would be happy to answer. Let's move ahead. So now let's look about, okay, I think I've missed a slide. No, that is, okay, so let's learn about the average speed, like we looked about the speed. Okay, speed is equal to distance upon time. So this is the basic thing that you knew. that speed is equal to distance divided by time. So this is the basic thing that you knew. Now we are introduced with a new thing, that is average speed. So what is the average speed? Let's say for a total distance, आप कोई distance travel कर रहे हो, but for the entire distance your speed is not constant. Okay, let's say the total आप 100 kilometers की distance travel कर रहे हो. For the first 40 kilometers you are traveling with some different speed, and for the remaining 60 kilometers you are traveling with some different speed. So with the help of this concept we will be able to understand what is the average speed for your entire journey. फिर उस स्पीड के साथ अगर आप पूरी जर्नी में अगर ट्रैवल करते हैं तो आप टोटल डिस्टेंस ट्रैवल कर पाते हैं. दैट इज व्हाट इज द कंसेप्ट ऑफ एवरेज स्पीड. Okay, so I have already included an example here. So let's try to understand it with the help of an example. If a part of a journey is traveled at a speed of x km per hour in p hours, and the remaining part at a speed of y km per hour in q hours. Okay, so like I told you, for a total distance you are not traveling with a constant speed. For the first part you are traveling with some different speed and you are taking some time, and for the remaining part you are traveling with some different speed and you are taking some time. Okay, so the total distance that you will travel, of course the distance, you know, distance is equal to speed into time. So what we will do is that for the first part the distance will be equal to speed, that is x kilometer, into p hours. So distance will be x times p for the first part, right? And for the remaining part it is y kilometer per hour for q hours. So what will be the distance in the second case? We'll add it here. Speed is y and time is q. So this is the total distance that you will be traveling here. And what is the total time that you are taking here? Let's denote it by t. So here you are taking p hours, here you are taking q hours. So what is the total time? P plus q. So what will be the average speed? As you can see here, the average speed will be this total distance divided by this time. So what is the essence of this average speed? So for example, if you are traveling with this speed for the entire journey, that is p plus q hours, then you will be able to travel the complete distance, right? So this is essentially what average speed means. I think this should also be very much clear to you. So I think we should move ahead. Let's see if you have any doubts. Okay, that's perfectly fine. I guess it is going fine without any doubts. Okay, so this is an important result for average speed. I think this will be very important for you to understand. This will also help you understand how conceptual topic time, speed and distance is. It is not just about learning the formulas. It is how you are able to apply what learning you are getting from this particular topic. Okay, so suppose a man covers a certain distance at x kilometer per hour and an equal distance at y kilometer per hour. I think it is completely visible. Okay, and an equal distance at y kilometer per hour. Then the average speed during the whole journey is denoted by this particular formula. Now one important thing to note about is here is that to calculate the average speed, there is no role of the distance that you are traveling, right? You can see the x and y that we are using here is just the speeds. So there is no role of the distance that you are traveling. So let's try to understand this. Okay, so let's say you are traveling a distance of d. So the distance that you are traveling, let's say you are traveling a distance d. Okay, and in the first case it was x kilometer per hour. Okay, so the speed, so there were two speeds, right? So the first speed be x kilometer per hour and the second speed is y kilometer per hour. So we are writing it as x and y kilometers per hour. So these are the two speeds with which you are traveling. So what is the average speed? We know the average speed is total distance being traveled divided by total time. So first we need to calculate the total distance. Since the same distance is being traveled two times, so total distance will be, so total distance will be 2 times of d, right? D distance in the first case also and same d distance in the second case also. So total distance will be 2 times of d. Now we need to see what is the total time for the journey. So time will be distance upon speed, right? We know that distance is equal to speed into time. Okay, so time will be distance divided by speed. Okay, so time will be, in the first case, because the distance is same, d divided by x kilometer per hour. So it will be d by x. This is the time. In the second case, time will be again the same distance, but it will be divided by y. So this is the time that we are taking. Okay, so total time will be d by x, just adding the two times, d by x plus d by y. This is the total time being taken. Now we need to calculate the average speed, denoting it by avg as speed. Okay, so average speed will be total distance, that is 2 times of d divided by total time. Here we can see the total time. Okay, so d divided by x plus d divided by y. So just solving this, we get 2 times of d divided by, I think it is clearly visible, or I should write it above. Okay, so I'm writing this here. So we have got average speed is equal to 2 times of d divided by d by x plus d by y. I'm writing this here, that it is 2 times of d divided by, let's take d common, it will be 1 by x plus 1 by y. So now you can notice here is that the d will get cancelled out. So the average speed will not depend upon the value of d. Whatever value you put, the d gets cancelled out. This is the very important thing that you need to note here. Because of this, we can of course solve it and get the value. So it will come out to be 2 divided by x plus y divided by xy, and xy will go into the numerator. So it will be xy here. So what you have, so you can see the formula here, that it is 2xy divided by x plus y, because whatever value you put for d, it will get cancelled out. So if you are traveling the same distance, then the average speed won't depend upon the value of distance. So we have concluded that with the help of this basic derivation. I think it is very much clear to you. I think I should clear so that I can explain the next part also to you. Okay. Okay. So we are done with this. If a man traveled for a certain time at a speed of x km per hour and traveled for an equal amount of time. See, here we were given that the distance is same for the two cases. Here we are given that the time that for which a person is traveling is same for the two cases. Of course, we have taken the speeds as x km per hour and y km per hour. So let's see how this goes. Okay, so let's take the time as t hours. So for t hours, we are traveling for the two journeys. So speeds will be x comma y. Of course, in kilometers per hour we will take, because we have taken this in hours. Okay, so for average speed, again we will need total distance divided by total time. So distance will be, let's say, denoted by dA. Distance will be, of course, we know distance equal to speed into time. The speed is, for the first person it is x km per hour. For the second person it is y km per hour. So dA will be speed of first person into time, that is t times x. Okay, and for the second person the distance will be speed of the second person is y km per hour, y into t. Okay, so now we have got the distances. So to calculate the average speed, so average speed will come out to be total distance divided by total time. What is the total distance here? This is the distance traveled in the by the first person, that is tx, and this is the distance that is traveled by second person, that is ty, divided by total time. Total time, we know that if t hours are being taken by each person, then total hours will be 2t. So we'll just divide it by 2t. Now just solving this, we can take t as a common, divided by 2 times of t. Again the t will get cancelled out. So what we will get is just the arithmetic mean of the two speeds. So this is the essential derivation of this second important result that you can see here. So if a man traveled for an equal amount of time for the two journeys with different speeds, then the average speed during the whole journey will be x plus y divided by 2. That we have just derived it here. I think this is also very much clear to you. So I think we should move ahead now. Let's see if it is clear. Okay. So now let's look at the relative speed concept. So if two objects or two persons A and B are moving with speeds x and y km per hour, then the relative speed between them will be x minus y km per hour when they are moving in the same direction, and x plus y km per hour if they are moving in the opposite direction. So let's try to understand this also with the help of an example. Let's say I am traveling from point A to point B, okay, and my friend is also traveling from this particular point A to point B. I think with the help of some numbers it will be better clear to you. Let's say my speed, should write a little larger. So my speed, let's say my speed is 50 kilometers per hour. Okay, and my friend's speed is 40 kilometers per hour. Okay, so I am traveling from this particular point to this point and my speed is 50 kilometers per hour and my friend's speed is 40 kilometers per hour. So every hour I am traveling 50 kilometers, my friend is traveling 40 kilometers. So essentially after 1 hour I will be ahead of my friend by 10 kilometers, right? So this is what this is trying to tell us, that every hour if they are traveling in the same direction, and the average speed will be, the speed will be x minus 5 km per hour. Because what is the speed, the distance that you travel every hour. So every hour I will be ahead by 50 kilometers and my friend will move by 40 kilometers. So the gap will be 50 minus 40, and that is 10 kilometers, that we can understand with the help of this formula. Okay, so let's assume for if they are moving in the opposite direction. Okay, so for the second case, if they are moving in opposite direction, let's say I am starting from this point and my friend is starting from that point. I am at this particular point, that is point number A, and my friend is at this point, that is point number B. The distance between 2 points, let's take the distance to be 360 kilometers. Okay, again the speeds to be, let's say my speed is 50 kilometers per hour, my friend's speed is 40 kilometers per hour. So my speed is 50 kilometers per hour, my friend's speed is 40 kilometers per hour. So essentially we are 360 kilometers apart. So every hour I'll move by 50 kilometers, my friend will move by 40 kilometers. So essentially out of 360 kilometers, together we have covered 90 kilometers. So now the distance between two of us will be 270 kilometers, right? So what we are doing is that we are adding the two speeds. So with that you can understand that I will travel 50 kilometers. So let's say I was here, I traveled 50 kilometers. So I am now here. My friend started from here. He started and he traveled 40 kilometers. So essentially we together have traveled 90 kilometers. So now the distance that is between us will be 360 minus 50 plus 40. So that is what this second case is trying to tell us, that if the two objects are moving in opposite direction, then the relative speed will be x plus y kilometers per hour. I think with the help of example it must be clear to you. This was all about relative speed. So I think we can move ahead now. Okay. So we can, in the train, time, speed and distance, we find so many questions that come from train also. So let's try to understand this also. Even though this is the simple application of the things that we have already studied. So consider two trains of lengths L1 and L2 traveling with the speed of S1 and S2 respectively, then they will cross each other in. Okay. So the time that they will take to cross each other will be L1 plus L2. So L1 and L2 are basically the lengths of the trains divided by their speeds. When they're moving in opposite direction, so it will be S1 plus S2. When they're moving in the same direction, it will be S1 minus S2. Because this is pretty much clear with the relative speed concept that I just told you. But let's say, you can ask why we are just adding the lengths of the two trains. So again, let's try to understand this with the help of an example. So let's say these are the two trains, lengths of the two trains. So these are the front ends of the two trains when they will be crossing each other, of course, on the parallel tracks. So the time will start. What time? Let's say the time that they will take to cross each other. The timer will start when the front ends will start, right? And if we, let's say, assume you are taking only L1, that is the length of, let's say, this particular length or this particular train, the length is L1. So when this train is crossing from this point to this point, let's say this train has crossed this point. This complete length of this train has crossed this point. From this point, let's say it is traveling, and from here, let's say, when I think it is clearly visible, when they are together, the front and rear end has passed the front end of this train, then you will end the timer if you will be taking only L1 length. So you can clearly see that the two trains have not crossed each other. Only when the rear ends of both the trains are crossing each other, then only you can say that the two trains have crossed each other. So even though, let's say, they are traveling in same direction or in opposite direction, you will have to add the lengths of the two trains. Then only you can say the time that is taken is the summation of lengths of the two trains divided by the relative speed. The relative speed I just told you in the previous slide. So we can understand that whenever any questions come from train, so we can just add the lengths of the two trains if there are two trains and divide by the relative speed to see what time they are taking to cross each other. I think that should also be very much clear. So we can move on to the next slide. Okay, so the next concept is boats and stream. So I have included some basic definition about boats and streams. So this refers to a category of problems that analyze the movement of a boat in a river or some water body with or without current. Current means there will be some speed of the stream also, right? So I have denoted it with current. Whenever you will be solving questions from boat and stream, you will be encountering these terms. I have included it in terms. First is upstream, second is downstream, then speed of boat in still water, then speed of current. Okay, so these are the terms that you will encounter whenever you will be solving boat and stream questions. Let's again take some example to get better understanding of it. Let boat's speed be m meters per second and speed of current, that is speed of stream, be r meters per second. So speed during upstream will be m minus r meter per second and speed during downstream will be m plus r meter per second. So what this is essentially trying to tell us, let's try to take an example for this also. So let's say in a river, even though my drawing is not that good, but try to understand it. So let's say this is the river and you are traveling in a boat. Let's say this is a boat in which you are traveling, okay, and you are moving with the speed of m meter per second. Okay, you are traveling with the speed of m meter per second. You are traveling from this point to this point. Okay, your direction is from this to this, and the speed of current is in opposite direction. So the speed of current, that is the speed of stream, it is essentially in this direction. Let's say the speed of current is r meters per second. So the current is moving from this direction to this, and my speed is from this direction to this. So essentially what is happening, every second I am traveling m meters in this direction and the river is pushing me back by r meters every second. So I think it will be more clear if we take some values to it. Let's say my boat's speed is 5 meters per second and the speed of current, that is r, let's take it to be, let's say, of course it should be less than 5, otherwise I won't be able to move ahead, right? If I'm moving, let's say, 5 meters and boat is pushing me by 6 meters, so I won't be able to move ahead. So let's say the speed of current is 1 meter per second. So what is happening here is that I am moving 5 meters in the forward direction and the river is pushing me back by 1 meter every second. So essentially, the distance that I will travel will be 5 meters that I am traveling ahead minus 1 meters that the river is pushing me back. Okay, so essentially it will be 4 meters per second, right? So this condition is called upstream when you are traveling against the stream. So you can see it here. Speed during upstream when you are traveling against the speed of current, that it is opposite to the direction of current. So the speed during upstream will be m minus r meter per second. Of course, the speed of downstream will be opposite to it when you are traveling with the speed of current, right? Let's say the speed of current is 1 meter per second, but the speed of current is in this direction. So what is happening now is every second you are traveling 5 meters and also river is pushing you in the same direction in which you are traveling by 1 meters. So essentially you travel 5 meters but the river has also pushed you by 1 meter every second. So essentially you will have traveled every second the distance of 5 plus 1, that is 6 meters is the distance that you will travel. Okay, this was about downstream. So these are the two very commonly used terms whenever you will be solving questions from boat and stream. And of course, speed of boat in still water means when you are traveling with your own speed and there is no use of the current, right? The speed, or you can understand it by that if the speed of current, speed of river or current is zero, right? So you when the speed of boat when the to calculate the speed of boat in still water, the speed of river or current you can take it as zero. There is no role of speed of current. You are traveling with your own speed only. That means speed of boat in still water. Of course, we have understood the speed of current. So I think this should be it for this slide. I hope everything must be clear so that we can move ahead. Okay, I think before linear race, we can practice some questions so that you can apply whatever you have learned today. So try this question. I think I can increase the font size. It should be clearly visible. So try to attempt this question. Okay, 90 seconds should be sufficient for this, and I'll try to explain it to you. Okay, so the time is up. Let's try to solve this question. Okay. So a person travels a certain distance. Okay. If he had moved at a speed of 1 kilometer faster, then he would have reached his destination 2 hours earlier. And if he had moved 1 kilometer slower, then he would have reached 4 hours later. Find the original speed. Okay. So we don't know the distance. So let's say the distance is equal to speed into time. So what we are given that is if he had moved 1 kilometer faster. So we are given the speed. So this is case 1. So in case 1, the speed is increased by 1 kilometer per hour. So speed is now s plus 1. So he would have reached 2 hours earlier. So he is saving 2 hours. So time is t minus 2. Of course, this is in kilometers per hour. This is hours. So the distance will be speed into time, that is s plus 1 into t minus 2, right? So there is one more case when he has moved at a speed of 1 kilometer slower. So case 2, in case 2 his speed is getting decreased by 1 kilometers per hour. Then he would have reached 4 hours later. So the time he is taking is 4 hours more than his usual time. So 4 will be added to his initial time. So this will be the case. So the distance will be just multiplication of speed and time, that is s minus 1 multiplied by t plus 4. So these are the two equations that we are able to form. Now we know that the value of d is s into 2. So we can simply substitute the value of d in the two equations. So I think I can substitute it here. So the value of d is s into t. So st is equal to, from this equation, s plus 1 t minus 2. Okay. So st will be equal to, just solving these two brackets, minus 2s minus 2. So this will cancel out. What we are left with is, okay, I think I have opened this correctly. Yeah. So 2 will come out on the left hand side. It will be t minus 2s. This is the first equation. Now we can substitute the value of d is equal to s into t in this equation also. Doing it here, again s into t in place of d. In the right hand side, just solving the brackets, it will be t into s, and just multiplying it, it will be t into s minus t plus 4 into s minus 4. So this will cancel out. What we are left with is, let's bring 4 to the left hand side. So it will be 4s minus t. So we are asked to find the value of original speed. So we need to calculate the value of s. So what we can do is that add the two equations so that the t gets cancelled out and we are left with only s. So just adding the two, I think I can do it here. For the left hand side, it is t minus 2s, I think it's visible, right? Plus 4s minus t. And on the right hand side, it is 2 plus 4. So like I told you, t will get cancelled out. We are left with 2s is equal to 6. Essentially, it means s is equal to 3 kilometers per hour. So we were asked to find the original speed, that was s. So the answer is option number C, that is 3 kilometers per hour. I think it should be clear. If you have any doubts, you can ask in the doubt section, in the comment section you can ask. Let's moving on to the next question, if it is clear. Okay, this is the second question. I've given only 1 minute because it is pretty easy. You can try this. Okay, try this. Okay, I think you must have tried this. So in this question we are told that it takes Ajay a total of 5 hours to walk to his office and drive back in his car. So we don't know how much time he is taking to walk and how much time he is taking to drive, but we are given that total he is taking 5 hours. So if he drives his car both ways, then it will take him a total of 4 hours. Find the ratio of the speed of walk and the ratio and the speed of car. Okay. So even though we didn't had much information in the first line, but we have so much of information in the second line. So if he is driving his car both ways, it is taking him a total of 4 hours. Now let's say if you are traveling from point A to point B by taking same mode of transport. Let's say you took a car, you move from point A to point B and using the same mode of transport. Let's say by car you are returning. So you are returning to point A, then the time that you will take to go from point A to point B will be same as the time that you will take from point B to point A if you are taking the same mode of transport, right? So we will be using this logic for this particular question. So we are given that if he drives his car both ways, it takes him a total of 4 hours. That means that let's say from going from his he is moving from his home to his office, right? So from his home to his office, if he is taking let's say X hours by car, then while he will be returning from his office to his home, he'll take again this X hours. So if he is moving from his home to his office by taking X hours, then for returning also he'll take X hours. So this 2x is equal to 4 hours that is given to us. So 2x is 4. That means x will be equal to 2. That means that for when he is driving, it is taking him 2 hours to cover his journey. So now we can use this information in the first line. Okay, it takes Ajay a total of 5 hours to walk to his office and drive back. Now we know that for driving it is taking him 2 hours. So for drive it takes him 2 hours. So out of total of 5 hours, 2 hours he is taking for driving. So the remaining 3 hours he'll take to walk, right? So walking it will take him 3 hours. Now we know the ratio of the time. We are asked to find the ratio of speeds. So the ratio of time taken to walk, I am denoting the time by walk as TW, is to the time that he is taking to drive, as time for walking is 3, time for driving is 2. Now the concept that I told you in the initial slides was that if the distance traveled is same, then if the ratio of time will be in the ratio A is to B, then the ratio of times will be in the ratio B is to A, right? That is 1 by A is to 1 by B, essentially B is to A. So we can directly use that concept here, that speed of walking is to speed of driving will be in the opposite ratio, that is 1 by 3 divided by 1 by 2. We can just take the LCM and multiply it by 6 to get it as 2 is to 3. Speed of walking is to speed of car, that is driving, is equal to 2 is to 3. That is option number D. I think that should also be very much clear because it was a pretty doable question. It is just that you need to understand this second line. Okay, so I think we can move ahead. So we have now a question from linear race. So let's first get back to our concept right here. So let's clear the concept of linear race. If A beats B by X meters in a race of 100 meters, then in this situation, the time of the race has to be same for both. Therefore, if the speeds of A and B be SA and SB respectively, then we can form this particular equation. There's one more condition here. If A beats B by T seconds in a race of 100 meters, this implies that both A and B are covering the entire 100 meter in the race, but the times are different. So therefore, this is the second equation or the second result. So let's try to understand this with the help of an example. Okay. So A beats B by X meter in a race of 100 meter race. So let's say the race length is 100 meters. So what is essentially happening here is that A is covering the entire race because he is winning the race. So he must have covered the entire 100 meters. So when A is reaching this point, that is the result point, the end point of the race, when A is reaching this point, then he is beating B by x meters. That means that B is behind A by x meters. So let's say B is here and the distance between B and A is x meters. So A is beating B by x meters. So B has covered a distance of 100 minus x. So total distance was 100. B is behind by x meters. So essentially B has covered 100 minus x meters. So the time will be same. Okay. So the time will be same because by the time A has reached this point, A has reached this point, B has reached this point. So in the same time, these things are happening. So the time for the two situations will be same. So now, because the times for the two situations are same, so now we can, let's say the speeds ratio is SA and SP. Let's take the speed of the first person. For the first person, let's say the speed is SA. For the second person, let's the speed be SB. These are the speeds. So because the times are same, let's equate the time. The time that A will take to cover this distance will be, we know that distance is equal to speed into time. So we are now, because the time is same, we can just equate using the time. Time will be distance. For A, the distance is 100 meters because he has completed the race. So that will be 100 upon speed of A is SA. And the second case, the time will be, let's denote it by TA. TA is the time that A is taking to complete the race. Now let's write the time for B, because B is able to travel 100 minus x distance because he is not able to cover the complete race. So the distance that is covered by B will be 100 minus x and his speed will be SB, we have assumed. Since the time is same for the two cases, we can just put the two equations equal. That is 100 divided by SA will be equal to this second term, that is 100 minus x divided by SB. Okay. So we can write this in the form of this also. When we are given, let's say A by B is equal to C by D. So we can write these two ratios as B by A divided by D by C. So we can write A by B is equal to C by D as B by A is equal to D by C. That is completely fine. So we are able to get to this result that 100 by SA is equal to 100 minus x upon SV. That is essentially what is written here. So this was the first condition. Now there is second condition also. In this condition, A was beating B by x meters, that is he was beating him by some distance. So in second case, A is beating B by t seconds, right? This means that both of them are completing the race, right? A started to run, B also started to run. So A has reached the result, well, A has reached the end point and B was behind, but after taking t more seconds, B was able to reach the end point. So essentially, both of them are completing the race. That means that both are able to travel a total of 100 meters. So the distance will be same in the second case. So let's try to understand that also. I'll just clear this out. Okay. So A and B, okay, A beats B by t seconds. So A as well as B both are traveling 100 meters because both are completing the race, right? So A and B both are completing the race, both are traveling 100 meters. So speed of A, B is A, speed of B we take it as SB. So because the distance is same, speed is SA and SB. So both are essentially covering the race, but the times are different. So what we can write is as, so time for A will be, we know again, distance is equal to time into speed. So time will be distance upon speed. Distance is 100 meters upon the speed of A. And for B will be 100 meters divided by B, right? And since B is taking t seconds extra, so this value is t extra than this. So by subtracting t from here, we'll be able to equate it with the first, that is TA. Okay, so TA is 100 divided by SA. So we'll be able to equate it with the second term by just subtracting t. So let's try to understand it with the help of some numbers. Let's say A was taking 25 seconds to complete the race and B was taking 30 seconds, that is t second extra. So he was taking, let's say, 30 seconds to complete the race. So what we have done is that from the 30 seconds, we have subtracted the extra t seconds so that we can equate the two equations. So now essentially what we can do is that t will be equal to 100 by SB minus 100 by SA. Right, this is essentially what we have written here, that t will be equal to 100 by SA minus 100 by SA. So I think this should also be very much clear to you. So now we can move on to the question that was on linear race. These two questions we have already done. So this is the question on linear race. With the help of that concept, I think you will be able to solve this. Try this out. 90 seconds are there. You can try this. So the time is up. I think I should now solve this question. Okay. So in a 400-meter race, A beats B by 40 meters and C by 80 meters. So A is covering 400 meters and he is beating B by 40 meters. That means B is behind the end line by 40 meters. So B has covered 360 meters. He has beaten C by 80 meters. So C is behind the end line by 80 meters. So essentially C has covered 320 meters. So if B and C run a 200-meter race at the same speeds as before, by how much does B beat C? So we don't need to see about A. We are only asked about B and C. So in the same time, B is traveling 360 meters and C is traveling 320 meters. So the ratio of their speeds, or ratio of their distance traveled by B is to distance traveled by C, will be in the ratio 360 is to 320. Okay, that is essentially, we'll just cancel this out. It will come out to be 9 is to 8. This is the ratio of the distances that are being traveled by them. So this tells us, the ratio tells us that by the time D travels 9 meters, C is able to travel only 8 meters. So if the race would have been of only 9 meters, then B would have beaten C by 1 meters, right? This is the difference. So if the, like I told you, if the race would have been of only 9 meters. So because B is covering 9 meters and in the same time C is able to cover only 8 meters, so B would have beaten C by 1 meters. But we are told that the race is of 200 meters. So the value of race is 200 meters. So the value of 9 is essentially 200. So how we will be able to make it 200? By multiplying it by 200 by 9, right? So if the value of 9 is 200, that is value of 9 is 200, then the value of 1 will be 200 by 9. We have just used the unitary method, and 1 was the distance by which B was beating C. So essentially with the help of just the ratios, we are able to get to the answer that B will beat C by 200 by 9 meters. So 200 by 9 will mean 22.22 meters. You can just do the calculations. I think the calculation would be very simple. It will be 9 to 18, 2, 9 to 18, 2 will be left. You will take some decimal and again it will continue. So you can do the basic calculations. It will come out to be 22.22 meters. So with the help of just the with the understanding and with the help of ratios, we are able to solve this question. I think this should also be very much clear to you, so that we can move ahead. Okay, this is a question from train. Again, this is a very good question. With the help of just the concept knowledge, we'll be able to solve this question in very less steps and in very less time. Just try to solve this question. Okay, I think 90 seconds should be sufficient to solve this question. Try this out. Yes, the black FZ guy, your answer is correct for the last question that you have written it as 22.22. Okay. Okay, so the time is up. Let's try to solve this question. So a train crosses a bridge of length 200 meters in 10 seconds. If it increases its speed by 20%, it can cross a pole in 5 seconds. What is the length of the train? Okay, so we don't know the length of the train. A train crosses a bridge, and also we don't know the length of the bridge also. So let's say the length of the train let's denote it by LT. Length of the train be LT, and length of the bridge be, let's say assume the length of the bridge be B meters. Okay, no, we are given the length of the bridge as 200 meters. So it is crossing the bridge in 10 seconds. So essentially what is being given is, we know the distance is equal to speed into time. So we can just use this. We don't know the speed, but we know the time. So time will be equal to distance upon speed. So distance is the length of the train, that is LT, and the length of the bridge, that is 200 divided by speed. We also don't know the speed of the train. That's denoted by ST. This is equal to 10 because we are given that it is taking 10 seconds to cross. If it increases its speed by 20%, then it can cross a pole in 5 seconds. So what this is essentially telling us, So 20% is equal to 1 by 5. I think you must have done the class of percentages. 20% is 20 divided by 100, that is 1 by 5. So what this means is that, so if we need to denote this in terms of ratio, then if initially the speed was 5, sorry, yes, it is speed, right? So if initially the speed was 5, then it has increased by 1 unit. Now the speed is 6. So we can denote the speed as from 5. So initially if the speed was 5, now it is 6 in the ratios. So because the distance is same, like I told you in the initial concept, that if the distance is same, then if the ratio of speed is 5 is to 6, then the ratio of time will be in the ratio B is to A, that is 6 is to 5. So now with the increased speed, it can cross a pole in 5 seconds. So crossing a pole in 5 seconds means that it is essentially covering its own length, because as compared to the length of the train, the length of the pole will be negligible, right? So essentially it is covering its own length in 5 seconds. So now we can see here that the time that the train is taking is 5 units. So the value of 5 units is given us as 5 seconds, right? So if 5 denotes 5 seconds, so this 6 will denote 6 seconds. Just reading the ratio. So time will be 6 seconds. So initially the train used to take 6 seconds to cross this pole. That means it was able to cross its own length. That is, it is able to travel its distance equal to its own length in 6 seconds. So we can frame an equation from this part also, that the length of the train is being traveled with the speed, we don't know the speed, right? That is st is equal to 6. Okay, like I told, because it is just crossing the pole. So crossing a pole essentially means that the train is just covering its own length. So length of the train is being traveled with the speed of st in 6 seconds. Initially it was 6 seconds. With the increase of speed, it is now taking 5 seconds. So we have two equations now. This is the first equation that we have. This is the second equation that we have. We can just solve these two equations. Let's try to put in some values. So the value of L T, that is length of the train, will be 6 times st, right? And we will just put this value in this equation to get to the answer. Okay, so LT will be 6 times of t. Putting it here, it will be 6 times of st plus 200 divided by st equal to 10. We can just solve this equation, solving it here. Okay, I'm solving it here. So 6 times of st plus 200, that is essentially equal to, multiplying it to the right hand side, it will be 10 times of st. So 200 will be equal to 4 times of st, that will give us st is equal to 50. St is the speed of train is 50. Because the units are meter and second, so the speed will be 50 meters per second. We were asked to calculate the length of the train. We can just substitute the value here. So the length of the train, okay, I think I should write it here. Length of the train will be equal to 6 times st, that is 50 meter per second. So it will come out to be 300. That is option number B. So this was the calculation. After you are able to form the equations, I think it is just solving it. The main thing was in this question was understanding this concept, that if the ratio of speed is from 5 is to 6, then the ratio of time will be from 6 is to 5, so that we can directly plug in the values, because we are given that by increasing the speed, it is able to cross the pole in 5 seconds. So this is denoting 5 seconds. So this will denote 6 seconds. So once we are able to get this equation, I think it is pretty much simple to solve. I think that should also be clear. If you have any doubt, you can put it in the live chat. Let's move ahead. Okay, this is a question of boat and stream. Try this out. So okay, so you have 1.5 minutes Try this question. Let's see if you have any doubt. So, Arnav Jha, this session will be 1.5 hours roughly. So the time is up. Let's try out this question. Okay. So a boat goes from point A to point B upstream in 6 hours and comes back from point B to point A downstream in 4 hours. If the speed of the stream is 1 by 5 of the speed of the boat, then find the distance between A and B. So the speed of the stream is given as 1 by 5 of the speed of boat. So let's assume the speed of boat B, let's say 5k. So why we are letting it as 5k? Because we are given that the speed of the stream is 1 by 5. So essentially we will have to divide this by 5. So just to avoid the fractions, I have let it as 5 times of k. So the speed of the stream will come out to be, let's denote it by S as 1 by 5 of 5k, that is k. So a boat goes from point A to point B upstream. Like I told you, for the upstream, we are traveling against the current. So our speed will be SB minus SS. So for upstream, effective speed will be 5k minus k, that is 4k. So time we also know it's 6 hours. Okay, let's first look at the, okay, let's frame the equation. So distance will be speed into time. Speed is 4k. Time it is 6 hours. That is 24 times of k. And from the second case, it is taking 4 hours to return downstream. In the downstream, the two speeds will be added because we will be traveling along with the speed of current. So downstream, it will be 5k plus k, that is 6 times of k. So the distance again will be speed into time. Time is 4 hours. Again, it is coming out to be 24k. But without knowing the value of k, we won't be able to determine the actual distance, right? So depending upon the value of k, if it is, let's say the value of k is 2, then it will come out as 48 kilometers. But if the value is 4, it will come out as 96 kilometers. So we can't really determine the value of total distance without knowing the value of the speed, right? So the answer to this question will be cannot be determined. We can't find the answer without knowing what is the value of speed. So I think this should be clear. So moving ahead, question number 6. Try this one. Okay, 1.5 minutes you have. Try to solve this question. Okay, so the time is up. Let's try to solve this question. Okay. If Ajay drives at 50 km per hour, he reaches office at 10 a.m. If he drives at 60 km per hour, he reaches office at 9:30 a.m. At what speed should he drive so that he can reach his office at 9 a.m.? Okay, so we don't know the distance from his home to his office. We also don't know at what time he's actually starting, right? We are given that he's reaching his office at 10 a.m. but we don't know at what time he's starting. And also we don't know the distance. So let's try to assume a few values. Let's say the distance between his home and his office be d. Okay, because it is in kilometer per hour, let's say the distance is d kilometers. So the time that he is taking, let's say it is t hours, because again we don't know the time at which he is starting, but we know that he is driving at a speed of 50 kilometers per hour. So we know that distance is equal to time into speed. So distance is equal to t into 50, that we know. So time will be d divided by 50. So that is the first thing that we can conclude using the first line. So in second it is given that if he drives at 60 km per hour, he reaches his office at 9:30. Okay, so even though we don't know at what time he is starting, but we have assumed that he is taking a total of t hours to reach from his home to his office. So by taking t hours, he is reaching at 10 a.m. So in order to reach at 9:30, it is that he is taking half an hour less as compared to this time. So for the second case, the time will be t minus 1 by 2 hours. Okay, so because he is starting at the same time, so for the second case, because the distance is same, that the distance is same, that because the distance is d only. Now his time that he is taking is, because he is reaching at 9:30, he is able to save half an hour. So time will get reduced by 0.5 or 1 by 2. So time will be t minus 1 by 2. Speed is given to us as 60 kilometers per hour. So speed will be 60. So again we can form the basic equation that distance is equal to speed into time. That is, speed is 60, time is t minus 1 by 2. So we are able to form this equation. Now we can just substitute the value. We can substitute the value of d as 50 times t. So here we can substitute this value. So it will be, I think I should solve it here. So d will be 50 times of t, substituting it in that equation. So essentially what we will get is 60 times t minus 1 by 2. Okay. So 50t will be equal to 60t multiplying it minus 60 divided by 2, that is 30. So 50t is equal to 60t minus 30. Taking 30 to the left hand side, it will come as 30 is equal to 10t, or t will be equal to 3. So this tells us that he is taking a total of 3 hours to reach from his home to his office. So if he is taking 3 hours and he is reaching his office at 10 a.m., that means that he started at 7 a.m., right? If he is starting at 7 a.m., he is taking 3 hours, then only he can reach at 10 a.m. Okay. Also, we can calculate the distance also, because we have the value of time, that is 3. So we can substitute it in any of the equation. Let's say I substitute the value of t in this equation so that I can calculate what is the actual distance between his home and his office. So let's try to substitute the value in this equation. So we will get d is equal to t times 50. T is 3. So 3 into 50, that is 150 kilometers. So we know that he leaves his home at 7 a.m. because he's, like I told you, he's taking 3 hours. He's reaching his office at 10 a.m. That means that he is starting at 7 a.m. So essentially, he is leaving his house at 7 a.m. And now in the second case, at what speed should he drive to reach his office at 9 a.m.? So because he is starting at 7 a.m., he wants to reach his office at 9 a.m. That means that he wants to cover that distance in 2 hours from 7 to 9. And we also know the distance is 150 kilometers. So we can just use the simple distance is equal to speed into time, of course. So we know the distance is 150 kilometers. We are asked to calculate the speed, and time we know because he is starting at 7 a.m. He wants to reach his office at 9 a.m. So essentially in 2 hours he wants to cover the distance of 150 kilometers. So we can just put in the value of t as 2 hours. So this will come out to be s is equal to 150 divided by 2, or 75 kilometers per hour. So the speed that he should travel at will be 75 kilometers per hour to reach his office at 9 a.m. So the answer should be option number B. I hope this should also be very much clear to you. A pretty good question actually. Let's try to move ahead. You can ask the doubts if you have in the chat box, in the live chat. Okay. This is the question number 7. Let's try this out. Let's see if you have any doubt. Okay, I forgot to turn on the timer. Okay, try this. I think we should start solving it. Okay. Just to save some time, I think we should start solving this. So Ram and Sham run towards each other from point A and point B respectively with respective speeds of 10 km per hour and 11 km per hour. After they meet at point C, they interchange their speeds and they continue running. So what is the ratio of total time taken by Ram and Sham? Okay, let's try to understand this question. Let's say these are the 2 points. This is point number A. This is point B. So Ram is starting from point A. Sham is starting from point B. And they are meeting at, let's say, this point. So Ram has traveled and then he will travel the remaining distance. Sham has traveled this distance and then he will travel the remaining distance. We just know the speeds at which they are traveling. So Ram is traveling at a speed of 10 km per hour. Sham is traveling at a speed of 11 kilometers per hour. So we don't know at what time they are meeting. Let's say they meet after t hours. Let's say the time after which they are meeting will be t hours. So t hours. So essentially, in t hours, at the speed of 10 km per hour, Ram will be able to cover a distance of 10 into t, right? Because distance is equal to speed into time. So Ram will be able to cover a distance of 10 into t. At the same time, Sham will be able to cover a distance of, because his speed is 11, so 11 into t, right? Speed into time will be distance. So 11 times t. So when they meet at this point, after this, Ram will be getting to travel this distance. Ram has covered this distance. So after they meet, Sham will have to travel this distance and Ram will have to travel this distance. But they have interchanged their speeds. So let's take the time, because we are asked to find the ratio of the total time that is taken by them. So total time taken by Ram, of course, t hours, because they are meeting after t hours. After this t hours, because Ram has to cover this distance, that is, this is the distance that Ram has to cover, and his speed is 11 km per hour, because they have interchanged their speeds. So this will be divided by 11. This will be total time taken by Ram. Also, we can find the total time that is taken by Sham. So of course, because they are meeting after t hours, so t will be common. After that, Sham will have to travel this distance, that is 10 times of t. So 10 times of t divided by, because initially the speed of Sham was 11, but they have now interchanged their speeds. So now the speed of Sham will be 10 km per hour. So this distance Sham will have to travel with a speed of 10 kilometers per hour. So this will cancel out. This will also cancel out. Ram will take 2 t hours. Sham will also take 2 t hours. So essentially, because both the values are same, so the ratio will come out to be 1:1, because both are taking same time. So it will be 1:1. Okay. Option number C. Both will take same time to cover the distance. So the ratio of total time taken by Ram and Sham will be in the ratio 1:1. I think that should be pretty much clear. Moving ahead to the next question. Okay, try this out. I think this is also a good question. Let's see. Okay, try solving this. See if you have any doubt. Okay, the time is about to get over. I think we should start solving this. So Narayan, okay, the time is up. So Narayan left his house at 10:20 to meet his friend at a restaurant and have lunch. He finished the lunch at 3:20 because 15:20 is essentially 3:20. On his way back, he realized that the time spent by him inside the restaurant is double the time that he took to reach the restaurant. At what time did he reach the restaurant? I think this is pretty doable question. Okay, so he is starting at 10:20 from his home. He is reaching the restaurant. Then essentially he is having the lunch, and he is finishing the lunch at 3:20. So what is the total time that he is taking to from leaving his home and to completing the lunch? So that is 3:20, that is in the afternoon maybe, and 10:20 in the morning. So essentially it is 5 hours time, right? So in total of 5 hours, he is able to start from his home, reach the restaurant, and also have the lunch. So in 5 hours, he's doing all the things. And we are also told that on the way back, he is able to realize that the time that he spent inside the restaurant is double the time that he took to reach. Okay, so in these 5 hours, if X hours he's taking to reach the restaurant, then 2x hours he'll take to eat the restaurant, because it is given that inside the restaurant the time that he is spending is double. So this is the time that he is taking while traveling, we can say it. And inside the restaurant he's taking 2x hours. So 3x is equal to total of 5 hours. So x will be equal to 5 by 3. So this is in hours, so we can easily convert it into minutes by just multiplying it by 60. This will give us 100 minutes. So value of x comes out to be 100 minutes. Okay. So what we just did is that, so to travel he was taking x hours. That means he was taking 100 minutes from his home to reach the restaurant. He left his home at 10:20. So after 10:20, he will be taking 100 minutes to reach the restaurant. Okay. So after 10:20, he will be taking 100 minutes to reach the restaurant. And after that, he will be taking the remaining time to eat the lunch. So what we are asked is, at what time did he reach? So we are just asked to get the time at which he reached the restaurant. So for 100 minutes essentially means 1 hour and 40 minutes. Adding 40 minutes to this will give us 11, and one more hour will give us 12. So he is reaching the restaurant at 12. I think this was pretty doable question, pretty easy. I hope this should be clear to you. So I think we can move ahead to the next question now. Okay, try this out. Let's see if it is clear. I think we should start solving this. Okay. So time is up. Let's see. I think this is also a doable question. If Helsinki takes 32 minutes to walk every kilometer and Nairobi takes 16 minutes to walk every kilometer, both of them participate in a race. If Nairobi beat Helsinki by 320 meters, then find the length of the race. Okay, so we are given about how much time they are taking to travel every kilometer. So let's denote it by H and this as N. So H is taking 32 minutes for every kilometer, right? And N is taking 16 minutes to walk every kilometer. So again, because the distance is same, so when the distance is same, so the ratio of time, that is TH to TN, that is equal to 32 is to 16, essentially 2 is to 1. Okay, so since the distance is same, so the time taken, we have calculated the time ratio of time. So the ratio of time is 2 is to 1. So now we can just look at the speeds also, like we have done in the initial. I have told you in the initial slides. So if the distance is same, that so if the distance is same, then if the ratio of time is A is to B, then the ratio of speed will be in the ratio B is to A. So the ratio of speeds will be in the reverse ratio, that is 1 is to 2. Okay, so now this is essentially telling us that by the time S covers 1 meter, by the time H covers 1 meter, N will cover 2 meters. So in the if the race would have been of 2 meters, N would have beaten H by 1 meter. So if N wants to beat H by 320 meters, so the difference, that is 1. If this difference has to be of 320 meters, then the race would have been of, like, so because N will cover the complete distance to win the race. So because 1 is representing 320, so we can simply multiply this by 320. So essentially N will also get multiplied by 320, that will come out to be 640, and we can multiply this by also 320 to get the distance that is covered by H as 320. So what we have essentially done here is that when N will cover 640 meters, H will cover 320 meters, and the difference between the distance that is covered by them is 320 meters. So N wants to beat H by 320 meters. So that can happen when N has covered 640 meters and the race should have been completed then. So by this logic, the race should have been of 640 meters, because now the race has ended and the difference between the distance that is covered by N and H is 320 meters. So that was given us here, that N wants to beat H by 320 meters. So the answer to this question will be 640 meters. I think this should also be very much clear with the help of this logic, that if the distance is same, then for the ratio of time to be in the ratio A is to B, the ratio of speed will be in the ratio B is to A. I think that should also be very much clear to you. If you have any doubt, you can ask in the chat box. So I think this was the last question for this session. Yes. So this was the last question. I hope this session was useful. So as I told you, more sessions are lined up. Okay. So see, tomorrow the session is on directions, then on fill in the blanks. So I would recommend you to just subscribe this channel so that you don't miss out on any of these classes. This will be very beneficial even if you are preparing for IIM Bangalore UG or maybe for the IP MET. These sessions are very helpful. So just subscribe to the channel. I think that should be it. Okay.